so I'm making another video. Oh, before I start, yes, I did get a haircut, so now I don't look like a mushroom. Yeah. Anyway, okay, so basically I just wanted to make like kind of an intermediate video. It's been a while since last time. I laid out some problems, some issues I was having, and I did some work, and I kind of hit a roadblock. There's basically one big problem that I'll talk about a little bit more later. But basically, some changes I made. I'm now using a 5-volt power source from the wall, so I can just like stick that into a breadboard, plug that into a power adapter. That works really well. Yeah, that's pretty much it. I guess I'll kind of show you what I've been doing in a close-up view right now. Yeah. Okay, so here we have, I guess, I don't know, kind of the new version, the 2.0 version of the adder. And it's just kind of a bunch of stuff, a bunch of sections put together. So basically here, these two things are those ICs I was talking about in the last video, the integrated circuit kind of things. So on this board here, there are all AND gates, see, because the transistors are facing the same side here, and then OR gates over here, two transistors facing opposite sides or directions. And then here, on this breadboard here, I basically have XOR gates. So I have this circuit here, not this, but I have this sum basically. So the idea would be to connect the sums to like these ANDs for the carry outs and that sort of thing, to make it a little bit more streamlined or more clear, basically. I have our inputs here. I got some cool switches, which should be kind of easier to pack in here, so I can decide what I want, and then I can keep them in a certain state, opposed to the buttons I had last time, which that was kind of a push button thing. It was a little difficult. I had to push down on one button to keep the input on. Anyway, yeah, so that's this. This doesn't really work. I started trying to connect the gates together, but I basically ran into this problem. So I'll discuss that right now. So here I have a simple breadboard, and I'll hook it up to power. Okay, so basically this is okay, so this is an AND gate that goes into an OR gate and then into ground. So it gets power. We have the output here. It goes through this LED. It has to go through these two transistors, then these two, and then it goes into ground. So the idea is when I connect this transistor to power, it turns on. Both these transistors need to be connected to power for it to work, and one of these transistors need to be connected to power for this to work. So if both of these are gone, it's obviously not going to work because this is an OR gate. So all I have to do is connect one more, and that works. So basically what I'm doing here, here, I'll get a close-up view. Why don't I just, I can zoom in. Yeah. Okay, so the output of this gate, the overall, I guess the emitters here of this transistor is being input into the collector of these two transistors, and then that goes to ground, and the inputs well, it's not exactly being input into. I mean, it is being input into the collector, but that's not exactly helpful in like a logic sense. That we don't want that. We want the output of one gate to be input to the bases of these transistors. So in other words, here we have the inputs for these transistors given from these resistors, basically, which are hooked up to power, and that's not what I want. Like I mean, it clearly works. It's easy to get like a single logic gate working with inputs from power using these resistors, but the problem arises when I want to connect circuits, the output of one logic gate into the input of another logic gate. For reasons here, I have another example set up here. Okay. So here we have an OR gate here and an AND gate that go into another AND gate. And the idea is if both of these gates are true, this gate is true, and this light should light. If this gate is true, this light should light. If this gate is true, this light should light. So we can hook this up to power. I'll find my power here. Okay. Oh, wrong power. Whoops. Gotta hook it up to here. Okay, so basically what we have here is these two gates. They're working correctly, right? This AND gate, these two transistors are powering, giving input to this AND gate. That's true. These two, I'm sorry, resistors are giving power to the transistors and the AND gate, and that's true. The light is on. Same here. When I take one of these transistors out, because this is an OR gate, it should still stay on. Still stays on, right? When I take a second transistor out, this should turn off. Yeah, great, that turns off. Oh. Well, actually, it doesn't turn off. Okay, so that's kind of part of the issue here with the outputs. Yeah. So basically, some of that power is allowed to get through this transistor because this is being hooked up to the output of this is being hooked up to the base here. The base is actually going through into ground, and there's still that small amount of power or voltage being supplied to this LED, so it is allowed to stay on. Ooh, this is bright, sorry. Yeah. You see that? Yeah, okay. Let's see, let's look at this side. So this is an AND gate, so if I take one out, it should turn off. Okay, so this one turns off completely because the output of this gate is connected to the base of the first transistor in this AND gate, which is it gets kind of confusing, and it's weird logic. Because it's connected to the first one, it has to go through that first transistor, which is okay, it's doing that, but it also has to go through the second transistor, and because that's not being toggled, this one won't turn on at all. So we get kind of a weird thing going on, and it's kind of confusing, and I'm not exactly sure how to ratify it and what the solution is. So basically my next step now is to do a little searching online, do a little browsing on YouTube maybe, and see if I can find a solution and see if anybody else has run into this problem. while attempting a project like this, and see if I can get any answers from them. Yeah. Okay, so here I have kind of a diagram of kind of what's going on here. This is not the exact same case. It's a bit of a different case. These are two OR gates connecting to an AND gate. So basically I have, I don't know, I said the output of this gate was alpha. I said the output of this gate was beta, let's say that, and then the outputs of these gates were going into the inputs or the bases of these transistors here, alpha and beta. Yeah, that's another, I guess that's on paper, kind of what I'm trying to do, but again, I'm having that issue where it's not as easy as it seems to hook up the outputs to the inputs. Yeah, so that's it basically. Okay, so yeah, that was it. I'm gonna get working on that. Gonna do some more research, hopefully find a solution, and get this thing done. And hopefully there'll be another video soon with something that works. I've got plenty of time on my hands, so that's what I'll be doing. Yeah. Bye.